Hey everybody, this is Mr. McKee again with SEC 210. Today we'll be going over Lab 9.2.6, which is using Wireshark to observe the TCP three-way handshake. So sync, ACK, and I'll show you the other stuff too. Alright, so here's our mini-net topology, same thing, that's running on our CyberOps workstation virtual machine. Alright, so the scenario, in this lab you will use Wireshark to capture and examine packets generated between the PC browser using the Hypertext Transport Protocol, or FTTP, and a web server, such as google.com. When an application such as HTTP or FTP first starts on a host, TCP uses the three-way handshake to establish a TCP session between the two hosts. For example, when a PC uses a web browser to surf the internet, a three-way handshake is initiated and a session is established between the PC host and web server. A PC can have multiple simultaneous active TCP sessions with various websites. Alright, we're using our CyberOps workstation virtual machine. Alright, so start up your VM, which I've already done that. Open up your terminal. Alright, I'm going to try to make this thing a little bit, well, I'm not going to make it any bigger because I'm having a whole bunch of terminals open. Alright, so what I'm going to do is, I'm going to highlight this. Yeah, typing this in, sometimes you get it incorrect, so. But will it let me paste? No, you know what? That's right, it won't let me paste it. I gotta fix that in my VM. Alright. Because I know up here I can go insert guest section additions, but I haven't got around to doing it. So lab, support files, scripts, CyberOps, topo.py. Alright, so CyberOps. Alright, notice their topology again. I'm at the mini-net terminal. So I'm going to open up host 1 and host 4. Remember, we're using Xterm, but remember they're case sensitive. H1, and then go back here, Xterm, H4. Alright, so 2 terminals open for 2 hosts. Alright, start the web server on H4. So we're going to let's see what my personal working directory is. So if I go to lab.support files, actually I'll do this, lab support files, scripts, edge, server start. Alright, so our web server should be running. For security purposes, you're not able to run Firefox from the root user account. On host H1, use the switch user command to switch from the root user to the analyst user account. Okay, so H1, analyst. Oh my gosh, that is so hard to see. Alright, so Firefox. Alright, so notice it opens up. This is running in H1. Alright, after Firefox window opens, start the TCP dump session in the terminal, node H1, and send the output to a file named capture.pcap with the V option. You can watch the progress. That's the verbose switch or option. Alright, this capture will stop after capturing 50 packets as it is configured with the option C50. Okay. I'm assuming it's here. TCP dump IH1 Ethernet 0 verbose option, do 50 packets, W home analyst. And see, I'm tabbing over to make sure it's finding that as a legit folder. Capture.pcat, and it's actually going to create this .pcat file. CBROPS. Alright. Quickly navigate to 172.60. Whoop. When it says quickly, I have to go quickly 40. Alright, so it's generating some packets. Alright, notice 50 packets captured, 54 packets received by filter. Alright, so it's kind of weird, but this is actually running. Alright. And notice H4 is actually running the web server, so it received a request for, with a GET for its website from host 40. 172.16.0.40. If I go here, IP config, what is it, IF config. Okay, the request, the client was this one. Alright, that's my H1, this is the host, this is this server, web server. Alright, so part 2. So part 2 is analyze the packets using Wireshark. Apply the filter to the saved capture. Let's see, where are they at? Alright, so we're in H4. Oh, start Wireshark on H1. Alright, so press enter on H4, I'm assuming. Start Wireshark on H1. Alright, it'll pop up. I'm going to kind of like minimize this. It's not running anymore anyways. Alright. In Wireshark, click File Open, because we've made our pcat file. Alright, capture.pcat. Notice we're in Home Analyst folder right now. So capture pcat. And you notice it was made today, so that's the correct one. Open that one. I want to filter by TCP. Alright, so that's what we got. Alright. So in this example, the first 3 frames are the interesting traffic. Alright. So notice our flags sync, ACK, and ACK. Alright, in this example, frame 1 is started through a handshake between the PC and server on H4. In the packet list pane, top section of the main window, select the first packet, which I've already done that. Alright. Click the arrow to the left of the transmission control protocol, which is the 4th section down. Alright. In the packet details pane, and expand it to examine the TCP information. Locate the source and destination port information. Alright, so destination port 80, unsecured web server. Alright, source port is 33310. Alright, you may have to adjust the top and middle window sizes with Wireshark to display information. Alright. So now you're going to answer, what is your TCP source port number? Alright, which is you. How would you classify the source port? Well, that is a port that actually is generated by your generated by the PC. It's not like a registered port. And then what is the TCP destination port number? Which is 80, and that's just unsecured HTTP. Alright, how would you classify it? It's a standard. Here, I'll show you guys all the registered port numbers. Let's see. Numbers. Like here's standard port numbers. Like port 80, HTTP. All right. So these are all your well-known ports. 80 sticks out. Down here 443 for HTTP secure ports. All right, and so on. Notice how it stops at 1023. All right, you got some registered ports, but notice my go all the way down to the end. (33310). 33. Notice how it's not a registered port or anything. It's just a port that's generated by the PC. All right, so which flag is set? I'm gonna move this bottom section down a little bit. See how the flag is right there? It's the sync flag is set. And notice when I highlight this, it's actually showing the ASCII and the hexadecimal number value. Right? What is the relative sequence number set to? All right. Sequence number is set to 0. Okay. You just remember that. All right. Select the next packet in line. In this example, it's frame 2. In my example, it's 30, but no sync-ACK. Notice how it swapped the sending and receiving IP address and the port numbers. All right, what are the values of the source and destination ports? Notice source port coming from the web server going to me. Which flag is set? Notice the flag. What is the relevant sequence and acknowledgement numbers set to? All right. So sequence number there is set to 0 still. All right. Notice acknowledgement number is a 1. All right, notice it has a little note right here in brackets. Next sequence number is 1. So we'll keep an eye on that. All right, so let's go to our third packet. All right. So examine the third and final packet of Handshake. What is the flag set to? So we had first had sync, we have sync-ACK, and we have ACK. So it's an acknowledgement packet. All right, the relative sequence and acknowledgement numbers are set to 1 as a starting point. The TCP connection is established and communication between the source computer and the web server can begin. So notice sequence number is 1 now. acknowledgement number is 1. Alright, flag, ACK flag. Alright, view the package using TCP dump. You can also view the PCAP file and filter for the desired information. Open a new terminal window, enter the man TCP dump. Alright, TCP dump. You may need to hit enter. Use the manual pages available in the Linux operating. Using the manual pages available in Linux operating system, you read or search through the manual pages for options for selecting the desired information from the PCAP file. All right, so you got a bunch of options down here. All right. And what's so weird though, it's like, it must be saying it wants me to go. It's not going to let me look at that packet. Alright, so to search through the man pages, you can use the / searching forward or the question mark, searching backwards to find specific terms, and N to forward to the next match, and Q to quit. For example, search for the information on the R option, type / -R, type N to move to the next match. What does the switch R do? If you were to scroll down here, alright, so what I'm going to do is I'm going to type in / R, and it finds R. Alright, R reads packets from file, which was created with the W option or by other tools to write PCAP or PCAP NG files. Standard input is used if file is, and then in parentheses, in quotes. Alright, so that answers what the switch R does. Or I keep saying switch, the option R. Alright, in the same terminal, open the capture file using the following command to view the first 3 TCP packets captured. Now, what's so weird though? This is opened in Wireshark and H1. I don't think it's going to work over here. Let's see. Let me list. Alright, actually packet capture.pcap is right there, so I can use it. Notice this was done in a, this is running in a different host. So basically that's a different different host or PC. Not really PC, but yep. So TCP dump R, and then home analyst capture.pcap, and working for TCP and 3 items or 3 packets. Alright, to view the 3-way handshake, you may need to increase the number of lines after the C option. Alright, so let's make this a little bit bigger. Alright, here's our first output. Notice here's timestamp, IP, source. That's the source IP and packet. This is the source, the destination IP address. HTTP, it's showing that instead of the port 80. Flags, a sync flag. Alright, notice down here they're reversed. And notice it's putting HTTP instead of port 80 again. Sync ACK, and then ACK. Navigate to the terminal used to start Mininet. Terminate Mininet by entering quit in the main CBROPS VM terminal window. So if I go over here, type in quit, all my host terminals close down. Alright, after quitting Mininet, type in here sudo mn c to clean up the processes started by Mininet. Alright, CBROPS. Alright, so it's killing all those processes. Notice process kill. Alright. Reflections, there are hundreds of filters available in Wireshark. A large network could have numerous filters and many different types of traffic. List 3 filters that might be useful to a network administrator. Alright, so just think about that. You guys already have Wireshark in your VM. You can look through there. Alright, if you start typing, you know, sky's the limit. There's a whole bunch of different things you can do. Alright, so I'll let you guys answer that. What other ways could Wireshark be used in a production network? Well, I'll let you guys come up with your own answer, but you can see what kind of traffic is going across the network. Like in this network, for our lab, there's a lot of extra things that are running, say, on our routers. A lot of protocols that don't need to be running really because we're not using them. They're just slowing down the network. They're creating network congestion. So we could that would be an indicator that there's what's happening. But also, if you have somebody infiltrate your network, you can, you know, kind of like notice that some kind of weird traffic is going across the network. All right, but that's it. Pretty quick lab, but definitely good. And if you're doing the National Cyber League, you'll be using Wireshark. So that's it. Thanks for watching.